I've seen the odd comment on how hard this is due to the fact there are alignment restrictions you have to follow. It's not really that hard. A couple of small tricks and problem solved. First up, the alignments. These are in words, by the way. Sprites have an 8K alignment requirement. This basically means you have 4 slots you can place them in. Tiles have a 4K alignment requirement. This basically means you have 8 slots you can place them in. BG maps have a 1K alignment requirement, thus you have 32 slots you can place them in. On to tile costs. In 8x8 mode, 4 color is 8 words, 16 color is 16 words, 256 color is 32 words. In 16x16 mode, 4 color is 32 words, 16 color is 64 words, and 256 color is 128 words. So what do you get for your 4K slot of tiles or sprites? 8x8, 4 color gets you 512 characters, 16 color gets you 256 characters, and 256 color gets you 128 characters. In 16x16, 4 colors get you 128 characters, 16 color gets you 64 characters, and 256 color gets you 32 characters. The sprites you also have 32x32 16 colors for 16 characters, and 64x64 16 colors for 4 characters. How many backgrounds do you need? Well, it depends on what you're doing. I will just cover the most common setup of mode 1. First question, 8x8 or 16x16? That is a game design question, but it does impact how big your screens need to be. Second question, how do you want to scroll? In 16x16 mode, one screen is now 4 screens large, so you only need to allocate one screen for all scrolling. 8x8 in 224 line mode, that is only 28 characters high, so you have 4 rows off the bottom of the screen, which is plenty enough to do vertical scrolling in. So you don't need to allocate 2 in a vertical layout for vertical scrolling. It can be nice, but you don't need it. Horizontal. Well, nominally, you do need a second screen on the side. Or you can take the, well, since this is on a CRT like how it's designed to be, you won't see it anyway. Or you can just use the rightmost edge as a new line and you won't be able to see it on a proper setup, just as Super Mario 3 did. And that's a fair argument, but let's be real. You have a SNES. SNES has windows, so you can set up a window to hide the Charsworth. 4 on the left, 4 on the right, C64 style. Now if somebody is playing in an emulator, they may notice the slight black edge inside the window. But if full screen on a 69 LCD, what's another 4 pixels of black really? And on a CRT, you won't even see them in the first place. Now you start the X scroll at -4. That is what Fire Emblem 4 Genealogy of the Holy War does, but it also snaps to 16 with the cursor. However, this is only if you are strapped for VRAM and just can't afford 2 screens. In 16x16 mode, if you're only scrolling in one axis, then you have room to fit the other screen in the other half, be it the right side for vertical or bottom half for horizontal. Just offset the H or V scroll offset. With the horizontal mode, since each screen only needs 14 rows for a total of 28, you still have 4 rows at the bottom of the screen. This is also true if you are doing horizontal only scrolling in 8x8 mode. 8x8 is a nice HUD size, isn't it? You could just put the third plane's data in the bottom row. You scroll the plane to get it into the top of the screen, then set a HDMI to turn the screen off past the bottom row. Now your third plane for HUD is free. Of course, if you want to use it for a full screen effects or other info, then you will need to add a full plane. But then when you have a text box up, the game screen is static, so you could just borrow another part of memory that is off-screen temporary for such cases. Now tiles. Now you see, the thing with tiles is you don't have to start counting from 0. So you have 2 screens and you scroll horizontally. So you have another 4x32 down the bottom on the second screen, which is 128 words, which for a 2-bit HUD tile in 8x8 gives you 16 tiles. 10 digits and 6 for player head, logo, coin, colon, etc. And you have 2 screens that are 2 screens wide, so that is 4 sets of 4-row slivers. The first one holds the HUD map data, then you have 3 lots of 16 tiles, which is 48 tiles. If that is not enough, you can keep going after the screens with the HUD's font. How do you get them when tiles must be 4K aligned? You set the tiles to be 0 and then increase the tile numbers to offset to the part of memory. Maybe you have a large speech bubble. Harvest Moon, for example. Again, the text box doesn't use up the whole screen, so you can fit the text box on part of the screen, turn it off when not needed, and then put the font after it. Use V-scroll to put it at the top or bottom. Just be sure to disable the third plane when it's not needed. Set the initial value in the NMI and then toggle it with a HDMA setup. Maybe you need 2 boxes, a la Fire Emblem 3. We don't need it in the middle, so turn it off and put your font in the middle. When you want it in the middle, vertical scroll the bottom to the middle and use the top and bottom to cover the middle of the screen while your font hides in the other parts. Once you have worked out how many screens you need, time to actually allocate things. The key algorithm with allocation is largest or highest constrained first. Thus, sprites. Due probably largely in part to the NES, typically you put your sprites in the upper 8K slot. End screen, you start from 0. For this example, 3 1x1 screens, 1 for each plane, so at 0, 1, and 2. Then we have 3 to 24 for tiles. But tiles need to be 4K aligned. You put your HUD tile starting in the bottom of 0, 1, and 2 and carry into 3, which gets you 112 4-color tiles. Then start your 16 color ones at 4K, which gives you 1280 8x8 and or 320 16x16 16 color tiles. You want planes 1 and 2 to be 2x1 or 1x2. So again, sprites at 24. Now screens 1 and 2 eat 2K each, so 0 and 2. Now put 3 at 23. You can slide it down by the 4 rows and pack the tiles into the top of it, and then fill down with your extra HUD tiles as needed. Now your main tiles start at 4K, but you now have up to 1216 8x8s and or 304 16x16s. 2x2s. Again, sprites at 24. So now each screen needs 4K, so 0 and 4. Again, screen 3 goes at 23. Same trick as the previous setup. Now tiles start at 8K, and you have up to 960 8x8s or 240 16x16s. Sprite allocation. Since the SNES gives you 2 sizes, you have 8x8, 16x16, 32x32, or 64x64, with a pick 2 option. 8x8 and 16x16 are the most common setup, but it depends upon your game. You might wish to go 32x32 and 8x8 if you're doing a visual novel style game, for example. Sprites and tiles are allocated in strips of 128 pixels wide, so you are advised to draw them that way. For sprites, you get up to 128 by 512 pixels. So that is the blank size you should draw on. The sprite and tile number is always at the 8 by 8 level, and the tile and sprites are laid out on the grid as they would be seen on screen. For example, a 16 by 16 sprite is tiles 0, 1, 16, and 17. A 32 by 32 is 0, 1, 2, 3, 16, 17, 18, 19, 32, 33, 34, 35, 48, 49, 50, 51. And 64 by 64, well, you get the idea, I'm sure. Following the algorithm from before, allocate your larger sprites first, then fill in the smaller ones in the gaps where you can. Although if you have dynamic sprites, always allocate them in strips of 128 pixels and put them up front. One last trick. There is a reason I put the sprites at the top. You may remember that I mentioned you can offset the upper 4K words of the sprites. Well, if you do that, when it is at the top, it wraps around to the start, so back to 0. If you have a set piece with a fixed screen, Mini Boss and Mega Man for example, since the screen is locked in a known position, you can shift the upper half of sprites into the screen memory and fill the off-screen areas with custom sprite data. Then when you want to resume, set the sprites back and let the scrolling engine clean up the sprite data for you automatically. See you next time.